Hello and welcome to Chapter 7, Section 1. Today we're talking about integer exponents. So we're going to get away from systems of equations for a little while. So basic memory, when you're looking at 5 to the 4th power, this is the exponent, this number we call the base, and to solve it you do 5 times 5 times 5 times 5. It's not 5 times 4 is 20, it's multiplication. Now, I want to walk you backwards logically and algebraically to teach you about different types of exponents. 5 to the 4th power is 625. 5 to the 3rd power is 5 to the 4th power divided by 5. 5 to the 3rd power is 5 to the 4th power minus 5 to the 1st power. 5 to the 3rd power is 125. We're going to do that again. 5 to the 2nd power is 5 to the 3rd power divided by 5. 5 to the 3rd power divided by 5. And that's 25. That's 5 to the 3 minus 1. See how that works? Let's do it again. 5 to the 1st power is 5 to the 2nd power divided by 5 to the 1st power. It's 5 to the 2 minus 1, which is 5 to the 1, which is 5. Now we're going to keep going. 5 to the 0 power is 5 divided by 5, which is 1. 5 to the 0 power is 1. This one messes people up because they think 5 to the 0 power should be 0, but 5 divided by 5 is 1. And then we're going to go to negative exponents. 5 to the negative 1 is 5 to the 0 divided by 5. Now 5 to the 0 is 1, and 1 divided by 5 is 1/5. And we can keep going with this. 5 to the negative 2 is 5 to the negative 1 divided by 5. Well, that's negative 2 is 5 to the negative 1 minus another 1. That's what negative 2 is. It's 5 to the negative 1, which is 1/5, divided by 5. Well, divided by 5 is the same thing as multiplied by 1/5. It's 5 to the negative 1 times 1/5, which is divided by 5. And that's going to give us 1/25. What I need you to see, the shortcut to all of this, because this is the logic, this is the algebra behind it, and now we're going to learn the shortcut. Basically, anything to the 0 power is 1 because it's going to be 5 divided by 5 or 7 divided by 7 or whatever it's going to be. And anything to a negative power is going to be 1 over that power. So 3 to the negative 2 is the same as 1 over 3 to the 2nd, which is 1 over 9. And that's it. 5 to the negative 1 is 1 over 5 to the 1. 5 to the negative 2 is 1 over 5 to the 2. Now you know why, and you understand why, so now you can ignore why. And now you can skip to the easy part. 5 to the negative 1 is 1 over 5. 5 to the negative 2 is 1 over 5 squared. 3 to the negative 2 is 1 over 3 squared. So we're going to try that. Now, some things I need you to remember because they're going to try and trick you up. Negative 3 squared is negative 3 squared. That squared only touches the 3, so it's negative 3 squared, which is negative 9. But in parentheses, negative 3 squared is negative 3 times negative 3, and that equals positive 9. So let's take that to our negative exponents. Negative 3 to the negative 2 is 1 over negative 3 squared, which is negative 3 times negative 3, and that equals 1 over 9. And negative 3 to the negative 2 is negative 1 over 3 squared, which is negative 1/9. Got it? Go over it again if you need to get it square in your head. But this is what they're going to be asking you questions about. So please pause here and do check it out numbers 1 and 2 on page 461. Pause here and come back when you're done. So check it out number 1. 5 to the negative third is 1 over 5 to the third, which is 1 over 125, and it's meters because it's a word problem, so you need a word answer. Number 2a, 10 to the negative fourth is 1 over 10 to the fourth, which means 1 over 1 with 4 zeros, 1, 2, 3, 4. B is negative 2 in parentheses to the negative 4, which is 1 over negative 2 to the fourth, which is 1 over 16. C, negative 2 to the negative fifth is 1 over negative 2 to the fifth, which is negative 1 over 32. And if you said 1 over negative 32, that's the same thing. It doesn't matter where that negative sign is, as long as there's only one of them. Negative 2 to the negative fifth is negative 1 over 2 to the fifth, which is also negative 1/32. Okay? Now, what happens when we add variables to this? What is x to the negative 1 when x equals 2? Well, that's 2 to the negative 1, which is 1 over 2 to the 1, which is 1 over 2. How about a to the 0, b to the negative 3 when a is 8 and b is negative 2? We're going to substitute those numbers right in. 8 to the 0 times negative 2, and b equals negative 2. b doesn't equal 2. So if we're going to do that to the negative third, we're going to put parentheses around everything that b is. Negative 2 to the negative third. Well, this equals 1, so we're going to ignore it. This is 1 over negative 2 cubed, which is negative 2 times negative 2 times negative 2. So there's these two negatives cancel each other out. I've got one negative left, so my answer is going to be negative 1 over 2 times 2 is 4 and 2 is 8. Negative 1/8. Does that make sense? Pause here, do check it out number 3 on the very bottom of page 461 and come back when you're done. So for 3a, p equals negative 3 for p equals 4. We're going to stick 4 in for p with a negative third exponent, which is 1 over 4 cubed, which is 1 over 64. 3b, 8a to the negative 2, b to the 0 for a equals negative 2, and b equals 6. Well, that's 1, so we can ignore it. And negative 2, because that's everything that a is, negative 2 to the negative 2 power is 8 times 1 over negative 2 squared, which is 1 over 4, and 8 over 4 equals 2. Please ask me if you have any questions. What happens if your negative exponent is in the denominator? If we've got a problem like 1 over x to the negative 8, 1 over x is the same thing as x to the negative 1. So x to the negative 1 times negative 8 is the same as x to the 8. If you have a problem like this with a negative exponent down here and a 1 on top, you can just flip it and take that negative out. Let's try it again. This one doesn't have a 1 on top. Negative 4 divided by k to the negative 4. Now this is the same as negative 4 times 1 over k to the negative 4. Now I can flip this and I can say negative 4 times k to the 4th, which is negative 4k to the 4th. Let's try another one. 3y to the negative 2 is the same as 3 times y to the negative 2, which is the same as 3 times 1 over y to the 2. which is the same as 3 over y to the 2. Just like we broke this down, we can unbreak it. Let's do another one. We're going to break these down into two different things. This is the whole number, so we're going to say x to the negative 3 times, and this is 1 over, a to the 0 is 1. We can get rid of that, and this is y to the 5th. Now, this is okay, but we need to fix this. So we're going to say 1 over x to the negative 3 times 1, nope, we don't need that negative anymore, 1 over y to the 5th, and we can multiply these together. 1 over x 3 y 5. And that is simplified. What we're doing here is we're simplifying things. We're not solving them because I don't know what k equals, I don't know what y equals, but we are making them simpler. So pause here and try check it out number 4 on the bottom of page 462 and come back when you're done. For 4a, 2 times r to the 0, m to the negative 3, we're going to break them up. We're going to pull out our 2. R to the 0 is 1, so we can drop that. And m to the negative 3 is 1 over m cubed. And so we're going to multiply 2 times 1 over m cubed to be 2 over m cubed, and that's our finished product. R to the negative 3 divided by 7, we're going to separate. We've got r to the negative 3 and we've got 1 over 7. Now r to the negative 3 is 1 over r cubed times 1 over 7 is going to be 1 over 7r cubed. For C, we have g to the 4th over h to the negative 6, and we're going to break those up. G to the 4th times 1 over h to the negative 6, which is really h to the 6th, and then we can multiply those together, g4h6. And that's it. So for section 1, the homework starts on page 463. You're going to do the evens, 24 through 76. And you're going to show your work. Your work is going to look just like this so I can see you break it down because this is section 1. They're just going to get more complicated. So please make sure you're on top of all your work. Okay? I'll see you tomorrow.